Hello, and welcome to another tutorial video for CSCI 2824, Discrete Structures. Today, we'll be covering the types of quantifiers and going through a few great example problems. To start, let's quickly review what the quantifier signs mean. This upside down A is the universal quantifier. It means for every. Thus, when we have the universal quantifier with an x, it means for every x. This backwards e is the existential quantifier. It means there is some. So, when we have the backwards e with an x, it means there is some x. Let's note that we can also have multiple quantifiers in a row, called nested quantifiers. When we work with these, we want to go from left to right. So we have a universal quantifier with an x and an existential quantifier with a y. This means for every x, there is some y. We'll also note that quantifiers can sometimes have negation signs in front of them. Thankfully, we can use De Morgan's law for quantifiers to deal with this. What we're going to want to do is push and flip. We're going to push the negation through and flip the quantifier. So, in the following, we'll push the negation through and flip the universal to existential. We can do the similar thing with this equation over here. Again, we'll push the negation through and flip the existential to universal. This will be a very handy trick when working with some harder quantifier statements. Let's now move into an example problem. Suppose we want to write the following English statement in terms of quantifiers. Every real number x has some number y such that x plus y equals 0. To start, let's pull out the quantifier statements. That would be every and some. We know that every is a universal quantifier and some is an existential quantifier. So we could write this as for every x, there is some y. Our parentheses will denote such that x plus y equals 0. Now, we can stop to think if this really makes sense. Let's say our x is 5. Is there a y that will make it 0? Sure, -5. Similarly, if x is 10, is there a y that will make x plus y 0? Yeah, -10. In general, if x is a positive number, then y will be that same negative number, and x plus y will equal 0. Now, let's move into a little bit harder of an example problem. We want to write the following statement so that there are no negations. We'll notice that we have quantifiers, but that will also have something that looks more like compound propositions over here. So we're going to want to use some of our logical equivalences. Let's begin by pushing this negation sign through and flipping our quantifiers. So we'll get the following. For every x, there is some y such that it is not the case that g of n is less than x and f of n is greater than or equal to y. Again, just remember that I pushed this negation through and flipped the quantifiers. Now, we'll notice that our negation sign is actually on the outside of these statements. Because these look like compound propositions, we can use De Morgan's law for equivalences to remove the negation sign outside and distribute it within. So, we'll get the following. For every x, there exists some y such that it is not the case that g of n is less than x, or it is not the case that f of n is greater than or equal to y. Now we've distributed these negation signs to the inside. What we can actually do to start getting rid of them is using relation by implication. So we'll get the following equation. For every x, there exists some y such that g of n is less than x. If g of n is less than x, then it is not the case that f of n is greater than or equal to y. So, by using relation by implication, we're able to get rid of this negation sign. Finally, we'll want to kind of think about what that negation actually means. If it is not the case that f of n is greater than or equal to y, we're actually just saying that it is the case that f of n is less than y. Similarly, if we said it was not the case that g of n was less than x, for example, we might say, oh, g of n is greater than or equal to x. So we can write the equation as follows. For every x, there exists some y such that g of n is less than x. If g of n is less than x, then f of n is less than y. And we have thus effectively removed the negation from this equation. Solving quantifiers can sometimes be tricky, so it's good to really break them down and think about what you're saying. By using De Morgan's law for quantifiers, and by really thinking about what is being said, you can make quantifier problems a little bit easier. Thanks so much for watching, and good luck.